All right, so Mr. Lamar, as you were walking me through the steps, so we say we would start off with the point A,
B.
and then we draw a line east of A. Then now we would go south of A to the point C. And then now we know the distance of BC. And we know that that is 7 kilometers. And we also know the distance of AC, which is 6 kilometers. All right, so our next step now is to calculate the bearings. So we draw our north line, and then now we have to calculate the angle from the north line. So it's the line, the north line to the line BC. We have to form an angle with the north line and that line. So we want to calculate that angle. Is that clear so far?
No, sir.
Now, in terms of the diagram, that's what I'm asking you. Is it clear how we get to this point?
No, sir.
All right, so let us see where you would have missed out from. All right, so let us go back to where we were coming from with this. All right, do you remember how we get to that point, Mr. Lamar?
Yes, sir. Yes, sir.
All right. Now, remember, because they give you the distance BC, we have to construct that line BC and put in a distance.
Yes, sir. We get that as well.
All right. Now, remember we say we are calculating the bearings of C from B. Now, which point comes after the word from?
B.
Which point do we draw our north line to?
Sir, write this on the last one. Write this on.
So it is the point B that comes after the word from. So you construct a north line from that point B. So you're going to draw a north line from the point B, and that's how we get that.
Yes, sir.
Right. Now, after we draw our north line, now we have to measure our bearings of C from B. Now remember that bearings is an angle from the north line. And because it is measuring the angle from that north line, so you're measuring the angle to the line C, and the line that C is on. So the line BC is the line that you're using with the north line, and it's the angle that you're measuring in a clockwise direction from the north line. So always, when you measure an angle using bearings, you're using your north line to do the angle, and you're going in a clockwise direction to the line where the other point is on. Is that clear to you now, Mr. Lamar? Mr. Lamar?
Yes, sir.
Do you understand the angle that we are trying to find here?
Sure, not really.
You see where I just draw this angle from the north line, come right around? That's the angle that we're trying to find.
Okay, sir. So you just, okay,
Yep.
sir.
It's the angle from the north line you always measure when you're measuring the bearings, you know. So you have to always draw that angle using the north line as one of the lines. And then you're looking at the opening of the north line with the other line.
Okay, sir.
Is that clear to everyone, Ms. Waysome? Are you following clearly what I'm saying? Are you understanding?
Yes, sir.
Ms. Cabrera?
Yes, sir.
Who else is there? Miss Green, are you there? Are you understanding, Mr. Arti?
Yes, sir.
All right. So
Yes, sir.
once you're measuring bearings, you have to have a north line from which to measure your bearings. All right, so you can't just draw an angle and measure it without the north line. All right, so with that said, now we know exactly what we are trying to calculate. So that's the angle that we're trying to find. Now, we don't know what this angle is, but we can call it some angle. If you want to call it theta, you can call it theta. All right, we may have to use different symbols when we are dealing with different angles. All right, we don't use the same symbol for two different angles. I have to use two different symbols. So if we call it theta, if we're dealing with another angle, we call it alpha or something else. All right, now based on this diagram, Mr. Lamar, you can mute your mic for me, please. Based on this diagram, students, now the question is, what do we know based on this diagram that can help us to calculate that angle? Is there anything that we can use in our knowledge that we can use to figure out that angle?
Can we use the sine rule, sir?
All right, now
Or it wouldn't apply to this.
you mentioned sine rule, but I'm going to remind you once again that there is a rule that we refer to as sine rule that is different from the sine ratio. So we can use a sine ratio in this case, not the sine rule. Is that clear, Ms. Mason?
Yes, sir.
All right, so you tell me now why you decide that you want to use the sine ratio. Explain to me why.
Because, sir, the angle would have been at B, and then we have the opposite side and the hypotenuse, sir.
All right, so, all right, how would that triangle with the angle outside that triangle, how would you use that triangle to calculate that angle outside the triangle? And we can
How would we use that, sir?
we can say that this is a right angle right here, because we would have known that these two lines, one is horizontal and one is vertical. So it means that they will form right angle right at A. So this is a right angle right here. So the angle that we're trying to find, Ms. Wilson, is this angle. But remember that this angle is not within the triangle. This angle is not in the triangle, let's say so. This is the angle that we're trying to find. It's not in the triangle. But we have that triangle. How can that triangle help us to find that angle? Now, you remember when I was saying early on with the cardinal points, if you have the cardinal direction at the center of a circle, and you go all the way around that circle, you would measure, you would have gone through an angle of what?
360 degrees.
360 degrees. So it means that this can go all the way around. All right, let me not use that. That's not working out. So But if we are to think about this as being the north, then we know that the south would go down here. We know that the east would go this way. And if we should complete this circle, we know that in terms of the angle of the entire circle, we would have a complete rotation would give us an angle of 360 degrees. So that by itself give us some information that we can use. So what we know about this angle at the first cardinal point, that would be a 90 degrees. This one would also be a 90 degrees. This one up here would also be a 90 degrees. So we know all of that. Now, is there anything that we see that we can use in relation to the triangle? Is there anything we can use here, guys? Now, one of the things that we are to consider is that suppose we go all the way around, all the way up to here. What would that angle be from the north line coming all the way around to here? What would that angle be?
Degrees.
270.
It would measure 270 degrees. So if the angle went all the way up to this line, we would have 270. All right, does that give you any clue at all what you could do to find this angle out here? We know that.
Sir,
So just
you
take away
don't try.
270 from 360. Minus 270 from 360, sir.
But if we
Sir,
minus 270 from 360 this way, we're left with this angle up here.
So you don't find the angle of B and subtract it from 360 degrees and 90 degrees, that would be left.
Angle within the triangle here.
Yes, sir.
And then subtract it from the 270. And then you get this one outside here. Because we
Yes,
know
sir.
that these two angles, if you add them, you would get what? 270.
Yes, sir.
Everybody following?
No, sir. Reverse a bit.
All right. What you're not understanding in this case, huh? Think about
All right,
it.
sir. What is the one where you have the arrow, sir? Right there.
All
Not
right.
the theater, the one that you have the little arrow.
The blue part.
I'm
The-
referring to the red part.
The blue part outside the triangle, that's the angle that we're trying to find.
Yes, sir.
But we know that with the triangle, we could find that alpha, the angle within the triangle. Are you seeing that?
Yes, sir.
So I'm saying if we have this entire angle from the north line come all the way up to here in the triangle, we know that the two angles will give you 270 degrees, right?
Mm-hmm.
So if we can find the angle within the triangle, which is alpha, we can subtract that from 270 to get theta.
Okay.
All right, so theta would be equal to 270 minus alpha. All right, so how can we calculate alpha now? That's the question. What do you know from previous classes? Guys, alpha is one of the acute angle in the triangle. It's a 90-degree angle. How can we find the angle alpha? We know two sides of a triangle, and we know the angle that we're trying to find. How are those two sides relating to alpha in terms of the trig ratios?
The sine ratio, sir.
Right, so you use the sine ratio. So how would we set this out now in terms of sine ratio?
So, angle, you have angle alpha, sir, equal to.
No, write out the ratio first, Ms. Reese.
Yeah, so sine.
Sine of what?
Angle alpha.
Sine of alpha, which is the angle, yes? Sine of angle alpha is equal to what?
AB, sir, over BC.
All right, so we can just use the numbers and move along. So sine alpha,
6/7.
6/7. All right. So what are we going to do next?
So we're going to divide, so 6 into 7.
All right, so do the calculation and what you get when you divide 6 by 7. Use your calculator.
So let me try to find it on my phone.
Anybody else can calculate it, you know?
Okay, sir.
0.857. How is that possible?
0.857. Anybody can confirm that? Mr. Lamar, can you check and see if that is correct?
Yes, sir, that is correct.
All right, so if we know the decimal of the ratio, how can we now find alpha?
Sir,
we
on
do
the
sine inverse, sir.
Exactly, so we'd have to find the sine inverse of 0.857. So write that out and tell me what you get.
I don't have a scientific calculator right now.
Whoever has one, please work it out. Mr. Lamar, you should have yours.
sir.
What you get?
Sir,
Yes, go ahead.
58.9.
All right, 58.9. So alpha is 58.9. Let us just
So you
round.
round it up to the nearest whole number, 59.
All right, so we're gonna say 59. All right, so that would be alpha, but we are not looking for alpha. What we want is theta. So theta is equal to what now?
59 from 2.
59.
From
So
270, sir.
theta is equal to 270 minus
59.
Or this thing is really giving me help this evening. All right, 59. When you subtract that, what you get? Theta is equal to what?
211, sir.
211 degrees. All right. Good. Is there any other way, any other approach you could take to this question? Because it's not only one way we can solve it. You know? We can use other ways. So I'm just checking to see if you see any other way you could do it. All right, so suppose suppose we did not subtract this from 270. What else could we use?
We could add it to the 90, sir, and then minus from 360.
We could add
Considering that we, because we would know that where the north line is, sir.
All right, so if we draw down this like this, remember early on I was talking about Z angle. I want to point that out to you too as well.
Okay.
If we draw this down like that, the north line coming down, this angle here and this angle here would be the same.
Yes, sir.
If we calculate this one to be 59, how can we find this one down here? If let's say that this angle here, inside here, if we call that, let's call that 5. What would the angle 5 be? What do we know about the two acute angles in a right angle triangle?
They are equal.
What do both of them add up to give you? What's the total internal? 90 degrees, right? So we know that 59 and 5 would be 90 degrees. So we could actually subtract 59 from 90 degrees to get this angle, which is 5. That would give you what?
$31, sir. You
Right.
said 59 from 90?
Yes.
31.
So it means that this angle here would be 31. And it means that we could determine that this angle on the straight line is 180. And we could add that to 31. And we should get the same 211. So add 180 and 31 and tell me what to get.
$211, sir.
Right, so that's another way you could approach a question. All right, guys, so I hope when you're approaching these questions, you don't just look from only one point of view, but just look and see the different approaches that you could come up with. All right. Any questions so far? Sorry, let me clear what is here and then I'll just go back through this. So we say that having constructed the diagram looking like this, we could now determine that the entire angle here would give you 270 degrees. And we know that theta plus alpha give you 270 degrees. And so alpha in this case will be equal to 270 minus theta. So we use the right angle triangle to calculate theta. So sine theta equal to 6/7. Angle theta is equal to the sine inverse of 0.857. Give you 59 when you round it off. So calculating now the bearings of C from B, we get 270 degrees minus 59, give it 211. All right, guys, is that clear to everyone? Raise your hand if it is clear to you guys. All right, maybe we may want to do another example before we get comfortable. All right, so let us look at another example, guys. Now, what I want you to do, I want you to take the time out, try to construct this diagram on your own. And then I'll give you about 5 minutes to construct the diagram. Then I'll ask somebody to walk me through the process of constructing the diagram. And then now from there, we can try to calculate what it is asking for. All right, so 5 minutes for this construction, guys. All right, so I'm back. Somebody should be able to walk me through now constructing the diagram. Ms. Waysome, is your turn.
Yes, sir.
All right, so tell me what to do.
All right, sir. All right. So the first part it says B is 5 kilometers due north of P, and C is 2 kilometers due east of P, sir. So what I did was to start a vertical line, a line that runs straight down.
Which point are
The
we
first
starting
point,
with?
yes, sir, straight down with the first point labeling B.
Yeah, but before you run a vertical line, we need to know which point started first.
Would have been P, sir.
Right, so you put a point P.
Yeah.
And then you're going which direction now?
Up, sir. North, up.
All right, so we're going north of P. So from P we go up, and which point are we going up to?
B, sir.
All right, so let's say B is about right here, there. All right, so we label the point B.
Mhm.
All right, so B is right here.
Yes, sir. And then C is 2 kilometers due east of P, sir. So where the point P is, we would draw a line from there going right across and labeling it C. So to the right.
All right, now let us put in the labeling for the line.
Okay, so 5 kilometers.
We have 5 kilometers. Now we have to use our number sense carefully. Now, if
Yes,
this is 5 kilometers
Mm-hmm.
and the other one is 2 kilometers, which one of the line is bigger?
5 kilometers, sir. The vertical line will be bigger. Longer.
Right. Longer. So it means that when we're drawing the other line, we have to bear
Yes,
that in
sir.
mind.
Yes, sir.
All right, so from here, from P now, we're going 2 kilometers.
Little distance across, yes, sir.
All right, so we're going right across. So it cannot be more than, say, about here.
Right.
All right.
Uh-huh.
And so that would have been at right angle.
Point. Yes, sir.
All right, so that would be C.
Yes, sir.
The C is a point. What else do we know?
All right. Go again, sir.
What else do we know now?
A ship started from C. Thank you very much. A ship started from C and steamed in a direction of 30 degrees. Now, sir, what I did was from point C, I draw the dotted north line.
All right, so we know that once you're having bearings, you have to draw a north line to the point that you're measuring the bearing from. You're measuring from C, so you draw a north line, dotted north line.
Yes, sir.
So you label your north line.
Yes, sir.
All right. Now you know that the ship is going on a bearings of
30 degrees.
So what we need to know, we have to do an estimate of what a 30 degree would be.
Degrees. Yes, sir.
Right. So you tell me now, bear in
So,
mind.
sir, me draw it from the same point C and just go up like me, I go upward to the north line, this is, sir, but me not draw it too big.
All right, so if we go across like this, that would have been 90.
Right.
The north line. So
Yes,
30 degree would be 1/3. So you cut the 90 in 3 equal parts. So this would be, say, 60. 30 would be somewhere about there.
Sir.
And then now you continue, go up to
Yes, sir.
How far are we going up?
Sir, me just bring it up to the north line, this one.
It says that a ship's steam start from sea and steam in a direction 30 degrees. All right, so you carry it up.
Yes,
So
sir.
the other part of the question is calculate the distance the ship had to go before it was now due east of B. So if it is to be east of B, it has to be in line with B on the horizontal.
Okay.
Right?
Yeah. So also it would stop right at
So
B.
it's right where it becomes east of B.
Okay.
All right. So the ship would now be, if we call the ship, give me a letter for the ship. All right, call it S.
Yes, sir.
And the ship would be right there. So let's say the ship is right here. What else
Yes,
now?
sir. Alrighty, so me stop.
All right, so the diagram is okay. So all we have to do now is to do the calculation that they're asking you to find.
Okay, sir.
It's a calculate the distance. The
The ship had to before it was
So
due
which
east.
distance they're referring to? So the ship start from sea and reach here. So it is
Yes,
talking